Welcome to myprojectbazaar.com. Our product title is High Performance Quasi-Z-Source Series Resonant DC to DC Converter for Photovoltaic Module Level Power Electronics Applications. Now we are going to discuss about our product abstract. The High Performance Quasi-Z-Source Serial Resonant DC to DC Converter as a candidate topology for the PV module level power electronics applications. The idea of MLPE is a allow operation to each PV module the maximum power point, and they ensure the best possible energy harvest. So in the MLFB concept could be classified the partial power processing converters. And the main focus of this process full power converter for the parallel connection of PV module. In the process, each PV panel is equipment of the microconverter with output connected in the parallel to central DC bus of the PV power system. The power high efficiency setup the DC to DC converters with integrated to the PV panel for tracking the MPP local. The galvanic isolation is essential to reduce the ground leakage current and grid current total harmonic distortion. The central inverter feed PV power to the grid. So microcontroller is the self-powered high-efficiency setup DC to DC converter, the galvanic isolation operations with the automation controller. The PV panel for the tracking MPP local, the galvanic isolation is essential to reduce the ground leakage current. The novel galvanic isolation series resonant Quasi-Z-Source DC to DC converters as the candidate topologies for the section. The single DC to DC power conversion, the primary inverter should operate with a wide input power range. The optimization of the efficiency could become the issue of the different approaches development of the better performance of the simplest structure based on the two interleaved flyback converters. In the process, we could be still refer the most popular power conversion approaches for MLPE system. The single-ended nature of the process main flyback topology is utilization for the isolation transformer and active clamp circuit process. The minimum voltage of stress the main switch in the conditions of wide input voltage and load regulations. Now we are going to discuss about our product flow diagram. In our process, initially source for the PV model generations block. So in the process, the MATLAB simulation have only solar array, so we must create the PV model using the solar array. In the process, PV model consists 72 solar arrays. Those have connected in series. When the in residence of the value in the given solar terminal, solar cell converts solar energy to electrical energy. After going to the input source, the input source design consists of the single renewable energy input source such as PV module. The PV gives the DC voltage input source for renewable and applications. The power conversion is the important attribute of the modern galvanic isolated DC to DC converters from PV applications. After going to the using the main support for the process IGBT switches, the insulated gate bipolar transistor also called IGBT, the something a cross between the conventional bipolar junction transistor and the field effect transistor, for that making the ideal semiconductor switching devices. The IGBT transistor take the best part of these two type of transistor, the high input impedance and the high switching speed of MOSFET with the low saturation voltage. The bipolar transistor combined together produce the type of transistor switching device for the capable for the handling large collector emitter currents. After we go into the DC to DC converters, the DC to DC converters generally So means convert the fixed DC to DC variable for the DC supply. We using the ZC based on the booster converters. The booster converters increase the voltage for the output, and it consists of 3 inductors, 2 capacitors, 2 diode, and 2 IGBT switches. These are connected to the circuit panel. After we go into the PWM generations. The PWM is the current of the based the pulse width modulations carried based on PWM uses predefined modulations. The PWM modulation single the peak of the modulation single always less than peak of the carried signal. The PWM is the modulation techniques to encode the message input pulse signals. Although these modulation techniques can be used to encode information for the transmission, its a main use for allow the control of the power supplied to electrical devices. After converting the process DC to DC, we go into the transformer. So now we are using the coupled transformer. Using the magnetic transformer can sometimes be used to provide DC isolation between the circuits. So the coupling transformer is most often when the device is used for changing the impedance level. Two main applications for the properties to radio and amplifiers and high power tube or RF emitters. So the feeding of the large antenna that radiate energy reach receivers distance for the miles. So finally we connected the load some load. So we have even using the resistor inductance some volt, we use the connector the distribution network as the system's power used the compensation of losses in the overall networks. The change in the power system load over time, that the load determine the rated power of the users. The random quantities may be used various value of certain probability. The actual power system load are always less than sum of the rated power all of the individual users. Now we are going to discuss about a product running procedure. In our process mainly we designed for MATLAB 2013 version using the Simulink tool. So we have library getting from Simulink library browsers. We search some whatever we need components is searched. So this is main library function for here the Simulink. This is separate options for the common used blocks and continuous and discontinuous signals, discrete signals. So all of you getting from the source and things. So we using the components library from here. After using that complete the design. So it is very important for that power guy. So power guy is a overall panel. We give the important for that input signal from the source AC or DC whatever the renewable source. So this is individual for the circuits, but we need using the common voltage source for that power guy. So it is overall panel for using the power guy getting from the voltage. So main power supply from here that power guy. So after we complete this process, so just running this process. So here this is a run button, just run and I have using the scope model. The scope model for that what are we getting the from voltage or DC AC voltages, what are the inputs and output pulse width generations models. So whatever we just verification the models for that using the only for the scope model. So just like that using the scope model we using the some, this is like that. So this is the current false for the input current and input voltage for the, so this is the input voltage IGBT characteristics and current, and then input PV voltage for the almost 89.7 something. So 90 voltage for the DC we getting from the PV panel, and output for that using the output for like this is the pulse with modulations. So what are they we giving the pulse, we generate the at a time we which time is we enable the high power we get from the output for the voltage. This is output voltage for the DC source. So we giving the voltage for the 90 voltage DC source, and we get the output voltage for the DC almost 500 voltage. So we just boosted our DC voltage. So after we going to the convert the process, so inverter AC inverter for that. So this is a AC inverter. We using the output voltage. So this is the inverter voltage for the three phase. We getting from the DC voltage, we convert to the inverter, we using the load. After we get receiving the high voltage, so this is the voltage for the almost 90, but DC to DC booster only we getting the high value of that. So this is the 500 DC voltage for the from the PV panel for renewable source. Like another renewables for like wind and the battery, for some whatever we using that, getting it from the PV panels. So most important for that inverter and the converter the process, just load connections and inverter process. Oh, this is the input voltage from. So thank you watching our video.